Okay. Let's get started. Before we start the webinar, I'd first like to acknowledge the traditional owners of the land on which we are meeting, and I pay my respects to the elders past and present and the Aboriginal elders of other communities who may be here today. Good evening, everyone, and good morning to Akim. Thank you for joining this month's webinar titled Diabetes and Air Pollution. I'm Sabrina Idrose, a Centre for Safe Air Postdoctoral Research Fellow, and I'll be chairing today's webinar. So in Australia, approximately 1.5 million people, which is almost 5% of the population, live with diabetes. While links with obesity and diet are well known, air pollution is also a significant modifiable risk factor. In 2021 alone, nearly 10% of diabetes-related deaths in Australia were attributed to air pollution. Today, we are privileged to have two esteemed speakers, Professor Joachim Heinrich and Yiwen Zhang, who will shed light on the relationships between diabetes and air pollution. Each speaker will present for up to 20 minutes, followed by a Q&A at the end. So please drop your questions and comments in the Q&A section below. Our first speaker is Professor Joachim Heinrich. Professor Heinrich is an internationally recognized epidemiologist with expertise in asthma and air pollution. He is the unit head of population studies at LMU and a retired director of the Institute of Epidemiology at Helmholtz Zentrum, Munich. He holds an honorary professorial fellowship at the University of Melbourne. His specific research interests include the long and short-term health effects of ambient air pollution, assessment methods of air pollution and green space, and risk factors for asthma and allergies, including air pollution and green space. He published more than 1,000 research articles with a Google Scholar H index of 165. He was awarded as highly cited researcher by Clarivet Analytics in recognition of exceptional research performance demonstrated by production of multiple highly cited papers. Professor Heinrich sits on numerous review panels, including for German ministries, the German Research Foundation, the EU, and WHO. Today, Akim will provide a narrative review of systematic reviews on ambient air pollution, particularly particulate matter and type 2 diabetes. We're very glad to have you here today, Akim. Over to you. Would you like to share your screen?
So, Sabrina, good morning, and good morning to everybody. Good afternoon to the rest of the audience here. Everybody can hear me, right?
Yes, we can hear you clearly, Akim.
Okay. Thank you very much, Sabrina, for your very kind words and the invitation to share some thoughts about a recent systematic review we have published. And this systematic review goes on ambient air pollution exposure and type 2 diabetes. And I will give you a little bit more insight about this systematic.
We can't see your slides. Can you share?
Just a second.
Yeah.
Just a second.
Okay, it looks good. Thank you.
Yeah?
Yeah.
You can see the slides, right? And so
Yes.
I will give you some thoughts about this systematic review and a little bit more about recent and more historical reviews in the past. And the outline of this talk will be, I will talk a little bit about background, potential mechanisms, and the methods of our systematic review, and then I will compare the findings of our systematic reviews and meta-analysis with some other systematic reviews. And then finally, I will come to some conclusions and a few points of discussions. I will focus my talk on particles. There are other ambient air pollution as well, but I will just present results on PM10 and PM2.5 particles. The potential mechanisms are related to the respiratory tract first, and this inhalation of ambient air pollutants through the respiratory tract cause some inflammatory reactions, oxidative stress, and activation of the innate immune system. And all these reactions could lead to disturbances of glucose regulations in different organs and organ systems. And at the end of the day, and these different potential mechanisms also could lead to diabetes 1 and diabetes type 2. And this is the topic of my talk, diabetes type 2. And Yiwen, hello. You will talk about type 1 diabetes, as I learned from the schedule. The first paper on air pollution and diabetes was only published 20 years ago. So the entire story is not so extremely historical and is extremely long. It was a paper from China, mainland China, which showed a very tiny effect on diabetes mortality risk in Shanghai in relation to a couple of ambient air pollutants. Since then, during the past 20 years, when you did a double check and search in PubMed, PubMed identified more than 3,000 papers, more than 3,000 papers on air pollution and diabetes. And the question is how to digest these huge amount of papers. And one potential solution is to use systematic reviews, to use of the summary evidence which were provided by others. And I know very well each of the doctoral students at the Melbourne University and in Chamali's group has to start with a systematic review. And this leads to a flooding of systematic reviews. And I will show you a brief overview of systematic reviews and meta-analysis on air pollution and type 2 diabetes. So here there are 6. And you can see from this slide that even the review articles who should identify also those papers which were identified in the previous reviews did not cover all the reviews. There's a lot of spaces which showed first, which could first show you that that some of the reviews missed articles, or the exclusion and inclusion criteria were different. So there is a rather mixed results of the ongoing meta-analysis on air pollution and type 2 diabetes so far. When you're looking at systematic reviews, you need to explore whether the authors nicely subdivided the systematic reviews by study design. So, and the key study designs are related to short-term exposure studies and long-term exposure studies. And both study designs are very different, and you should not mix up these study designs. Short-term effect exposures are related, looking at the exposure in the general population or also on diabetic patients group, and looked at diabetes mortality or all-cause mortality in diabetic patients. While long-term exposure studies in relation to the onset of type 2 diabetes, they are always looking at air pollution in the general population and following them up and studying diabetes prevalence or diabetes incidence. So which is important, always a differentiation between short-term effect studies with long-term effect studies. When you're looking at the long-term effect studies, which are focused on my talk, though there were a couple of studies published so far, and just to get an overview, there are just might indicate there are statistically significant association. As the ambient air pollutants are different across the different studies, and in brackets, the increased risk is not statistically significant, and the circle means 0. There is almost no there's no association. These are the first studies. When you're looking at the more recent ones, the pluses were increased, which showed that the more recent studies, there was a tendency to identify a positive association between a set of ambient air pollutants and diabetes prevalence. How it looks like for diabetes incidence, overall, there are less studies, but the results look mixed. But there is one important issue to mention here. There is no single study which showed a beneficial effect when you are exposed to ambient air pollutants. So what does it mean in terms of a meta-analysis? Not all of these studies could be used for meta-analysis. And here we have particles, PM2.5 particles, and diabetes prevalence. Overall, there is a statistically significant association with a 7% increase per 10 microgram per cubic meter PM2.5 increase, and it is more or less the same for PM10. A similar results looked for incidence. Again, for PM2.5, there's a statistically significant increase with PM2.5 and diabetes incidence, and a few studies looked at PM10 and diabetes incidence. These studies were more or less the previous one and the more historical studies, but they also found increased risk, but this increased risk was not statistically significant. So again, one weakness of previously published systematic reviews are related to missing papers, so which could be very easily identified who was missing the papers. So missing papers are not nice for the overall results of the systematic reviews. And there are other weaknesses in the published systematic reviews, and I give you another example. These are typos and wrong scales. Here, they used the wrong effect estimate for this paper and also for this one. And also this paper here was, they used prevalence data. However, this systematic review is on incidence of diabetes. And when you are, and if you would correct these typos and wrong scales and the mixture of prevalence with diabetes, prevalence, incidence with prevalence papers, then the overall effect estimate is wrong. So the entire, this systematic review comes up with the wrong overall results due to some issues I try to highlight here. And I guess this is also the case of other systematic reviews. It is not a unique scientific or research activity of these authors. There's another common mistake and errors in systematic review, and this one is to use data from the same study twice. So here they came up with 5 studies, but actually these are just 2 studies. And that means the overall finding is also not the right one. And so this normally you should also use the data of the most recent published study, which covered a longer follow-up time. And so double usage of papers, published papers from one study is not the right way. So what about the 3,000 papers, how to digest? So systematic reviews might be an option. However, the results are different. And this raised the question, which systematic review could be used? And one common thought solution is just to use the most recent systematic review. And the most recent systematic review was published a couple of months ago. And this forest plot is shown here, which showed PM10 and PM2.5 effects on diabetes prevalence. And when these effect estimates were compared with our study, which were published a few years before, here they used 4 studies. We identified 6 studies and came up with a different overall effect estimate for PM10. And this study for PM2.5 is more or less the same. The paper by Josh identified 3 studies. We could identify 11 studies. The effect estimates are also different. And so that means even the most recent study leads to different overall effect estimates and came up with different overall effect estimates. And this is also the case for PM2.5 and diabetes incidence. Here they came up, the most recent one came up with 1.05 overall effect estimate, but we have published an overall effect estimate of 1.10 based on 11 studies. And so that means one of the difference, and this is a huge difference between the 2 overall effect estimates, and these major difference is mainly caused by missing some important studies within the most recent systematic reviews. So, common thought, most recent systematic reviews does not help. And what we can do if some of these systematic reviews are misleading, and even the most recent systematic review could not give the final answer. So that means systematic reviews have a lot of limitations. From the practical point of view, it's excellent, but they have to struggle with publication bias. They have to struggle with some uncertainty in the exposure. They have to struggle with uncontrolled co-exposures, differences in the outcomes, which makes it very complicated to harmonize the overall effect estimate across the different studies. So this study showed you a little bit a potential confounding by other pollutants caused by a rather high correlation. So that means actually we should try to do multi-pollutant models, but almost no study, no systematic review did so far a multi-pollutant modeling for summarizing multi-pollutant models in a systematic review and meta-analysis. Another example is on potential confounding by cofactors. And here, this is a systematic review on greenness exposure and type 2 diabetes. And greenness came up with a strong beneficial effect on the onset of type 2 diabetes. This paper was published a couple of years ago. And so if you ignore the greenness as a co-exposure to ambient air pollution, you might simply estimate a lack of greenness instead of adverse effects of air pollution. And similar difficulties arose when you do not consider noise as a relevant co-exposure. So strengths of comprehensive systematic reviews, increasing numbers of high quality studies. You have to include in particular studies with big sample size of cohorts, consistent findings of short-term and long-term effects are important. Some consistencies need to be considered when you're looking at the effects of amide and diabetes in relation to predisposing conditions and diabetes. And finally, you should always consider biologically plausibility, and which needs to be even by experimental studies and animal experiments. So the conclusion I would like to bring up here, you have to be very critical with systematic review findings. This is very important because just to use the data as it is sometimes, it could be misleading. There is no other way than to read the original work, the original published papers, which is a challenge, but we have to do that. And high-quality meta-analysis shows significant associations between particulate matter exposure and type 2 diabetes, but there's also some heterogeneity across the studies, and the clarification on the reasons of these heterogeneities are also very important. Most published papers are from North American and Western European populations, but recent studies also from China. There's also almost no study published so far from Africa, where the air pollution levels are high and also the diabetes prevalence is high. So our current knowledge is mainly based by some specific regions or continents which were highly investigated. Nevertheless, the effect sizes are small compared to other risk factors like obesity for diabetes, but air pollution is ubiquitous and can be avoided, especially in urban areas, which leads to a high public health impact. Taken together with results of experimental studies and investigations on predisposing diabetes-related outcomes, there's evidence for an association between air pollution and type 2 diabetes. And this is my final conclusion on the topic of air pollution and type 2 diabetes, and to highlight some potential pitfalls when you're considering the systematic review and the meta-analysis as the ultimate truth of this association. And finally, I would like to thank my co-authors for our systematic reviews, and also my fellow co-authors from Munich University. So thank you very much, and I'm happy to take your questions.
Thank you so much, Joachim. That was a very interesting presentation and very insightful. There are no questions yet in the chat, but we always do the Q&A at the end anyway. So attendees, please drop your questions in the Q&A section. We'll move on to the next speaker. The next speaker is Yiwen Zhang. Yiwen is currently a PhD candidate at the School of Public Health and Preventive Medicine, Monash University, and a member of the Climate Air Quality Research Group. Her research interests include planetary and environmental health, with a particular focus on the health impacts of wildfire air pollution. Yiwen has published several studies in top-tier journals such as Diabetes Care and Environment International. Today, Yiwen will talk about her recently published paper titled Short-Term Exposure to Wildfire-Specific PM2.5 and Hospitalization for Diabetes Morbidity, a study in multiple countries and territories. We are very thrilled to have you join us here today, Yiwen. Would you like to share your screen?
Sure. Okay. Okay, can you see my screen?
Yes, we can see your screen. Thank you.
Okay. Thank you, Sabrina, for the introduction. Good afternoon, dear all. Thank you for joining me today. In this presentation, I will introduce the health effects of wildfire fine particulate matter on diabetes hospitalization. The world has seen numerous wildfire events over the recent decades. Have we ever have an idea what wildfire is, which is often referred as bushfire in Australia? Wildfires, often perceived as a singular phenomenon, refer to unplanned and uncontrolled fires that burn in a natural area, such as in savanna, peatland, and forest. Wildfires can have destructive impacts on both the ecosystem and human health. Climate change has caused increased wildfire risk factors such as higher temperatures, longer wildfire season, lower humidity, less rainfall, and higher wind, because hotter and drier conditions are drying out ecosystems and increasing the risk of wildfires. That is to say, wildfires are projected to have higher frequency and stronger intensity in the future, and these can pose greater threats to human sustainability. Most research to date on the human health effects of wildfires have predominantly focused on wildfire smoke, which consists of complex mixtures, including particulate matters, carbon dioxide, nitrogen dioxide, and ozone. Often, PM2.5 is of significant concern. PM2.5 refers to airborne particles with a diameter of 2.5 micrometers or less. Due to their small size, these particles can be easily inhaled and penetrate deep in the respiratory tract, even reach the bloodstream. Subsequently, it can cause a series of adverse health outcomes in humans. As the main component of wildfire smoke, PM2.5 shows higher toxic effects compared with an equal dose of urban-sourced PM2.5. As our understanding of environmental health depends, it has become increasingly evident that air pollution is not just an environmental issue, but a critical factor influencing the prevalence and severity of non-communicable diseases like cardiovascular disease, respiratory conditions, diabetes, and even certain cancers. Today, we mainly focused on diabetes. As one of the leading NCD worldwide, its prevalence has been increased in recent decades and is expected to reach over 642 million by 2040. Two major clinical phenotypes of diabetes are type 1 and type 2 diabetes. Type 2 diabetes has affected approximately 9% of the population and accounting for 2.7% of mortality worldwide. Diabetes was estimated to cause a $1.31 trillion economic loss in 2015. Additionally, diabetes not only reduces life quality and expectancy, but can lead to severe comorbidities, including blindness, kidney failure, myocardial infarction, stroke, food ulcers, cancers, and even mental issues. This significantly drives up healthcare costs and is particularly concerning in developing countries. In this context, identifying potential contributors to diabetes is essential for preventing decompensation of this widespread and costly disease. As in a previous systematic review by Professor Joachim, air pollution is a well-established risk factor for diabetes. The possible mechanism is through impaired endothelial function, systemic inflammation, mitochondrial dysfunction, and oxidative stress, all of which are hallmarks of type 2 diabetes. Moreover, recent evidence also indicated that PM2.5 may also contribute to the incidence of type 1 diabetes, in addition to the genetic factors, possibly via impaired pancreatic beta cell and immune cell function and immunomodulation. However, there are few studies on associations between diabetes and short-term exposure to wildfire PM2.5. Current studies often limited to specific countries and wildfire periods. Furthermore, prior investigations proxied PM2.5 sourced from wildfires as total PM2.5 during wildfire events, making it challenging to disentangle the health effects of wildfire and non-wildfire PM2.5. Therefore, a multi-country study with extended spatial temporal coverage is warranted to advance the comprehensive assessment of wildfire PM2.5 associated health impacts on diabetes. To address these research gaps, we conducted a study to evaluate the association between short-term exposure to wildfire PM2.5 and diabetes hospitalization across multiple countries and territories. This study had just been published in Diabetes Care Journal. Through this study, we aim to explore associations between short-term exposure to wildfire PM2.5 and diabetes hospitalization for different types and countries' territories, to identify the vulnerable populations, to quantify the number and proportion of diabetes hospitalizations attributable to wildfire PM2.5, and to compare the risk and burden of diabetes hospitalization associated with PM2.5 from wildfire and non-wildfire sources. Our data were collected from 1,008 communities across 7 countries and territories: Australia, Brazil, Canada, Chile, New Zealand, Thailand, and Taiwan. Communities with relatively high rates of diabetes hospitalization were those in Thailand, Brazil, Chile, Canada, and New Zealand. The highest daily wildfire PM2.5 concentrations were observed in Chile, Central West Brazil, Northwest Canada, New South Wales of Australia, and Thailand. The information on the location characteristics is shown in this table. Different numbers of communities from different countries and territories are included during varying periods between 2000 and 2019. Overall, the average period covered in our data is about 16.1 years, and the median area across the study communities is about 5,292.1 square kilometers. We further aggregated the individual hospitalization data into standard time series daily counts by sex, age, location, community income level, and disease type. We included 5 types of diabetes in this study, which is defined according to primary diagnosis coded by the International Classification of Disease Tensorization Code. They are all-cause diabetes, type 1 diabetes, type 2 diabetes, malnutrition-related diabetes, other specified diabetes, and unspecified diabetes. A total of 3,612,135 diabetes hospitalizations were included. The highest proportion comes from type 2 diabetes, which is about 41.4%, followed by unspecified diabetes, which is around 29.7%. For our exposure of interest, wildfire PM2.5 was estimated through chemical transport model and machine learning calibration. The detailed methods can be found in our previous work published in Nature. Briefly, population-weighted daily PM2.5 sourced from wildfires was assigned to the health data according to the patient's residential address. For the statistical method, I will give a brief description here. More details on the model specifications can be found in the paper. Briefly, a well-established 2-stage analytic framework was utilized to characterize associations between wildfire PM2.5 and diabetes hospitalization. Through this framework, we derived the risk estimates by comparing the hospitalizations of diabetes on days with relatively higher wildfire PM2.5 to those with relatively lower exposures within each community. To be specific, in the first stage, a generalized additive model with a Cauchy-Poisson distribution was applied to model the associations in each community. In the second stage, random effects meta-analytic model was used to pool the community estimates to generate the overall estimates. The pooled estimates were presented as a relative risk with 95% confidence interval with a 10 microgram per cubic meter increase in white-fire PM2.5. The descriptive statistics of the study population was in this table. More male than female patients were hospitalized for diabetes. Except for type 1 diabetes, the hospitalization of all the other types of diabetes tended to increase as age advanced. Around half of the hospitalizations were collected from Brazil for all-cause diabetes, which is around 45.6%, and type 1 diabetes, which is around 61.2%, while a marked number of 34.9% of type 2 diabetes were from Thailand. This is a lag pattern for the risk of diabetes hospitalization associated with white-fire PM2.5 over the current day and the previous 7 days. This figure reflects how many days the effect of white-fire PM2.5 can last. The y-axis denotes the risk of being hospitalized for diabetes, which is RR. The x-axis is the day of exposure. Our preliminary analysis suggests that for all the diabetes, the effect of white-fire PM2.5 persisted for 4 days. After that, the RR is stable around 1, which means non-effect. In other words, white-fire PM2.5 would have adverse effects on diabetes hospitalization over the current day and the previous 3 days. We call this as lag 0 to 3 days here. And we thereby focused on the cumulative effect over lag 0 to 3 days in our further analysis. And this is the exposure-response relationships between white-fire PM2.5 and diabetes hospitalizations over the lag 0 to 3 days. This relationship provides a clear indication of how increases in white-fire PM2.5 are directly associated with higher hospitalization rates for diabetes. Overall, the exposure-response relationship presented a monotonically increasing superlinear pattern, meaning that even small increases in white-fire PM2.5 can lead to significant increases in hospital admissions for diabetes. In our subgroup analysis by sex, age, community income level, and country territory, we found that white-fire PM2.5 associated risks of diabetes hospitalization were not modified by sex or age, but by community income level and the country territories they located. Stronger associations were observed among individuals from high-income communities for type 2 diabetes, compared to those from communities with lower income. Meanwhile, for most types of diabetes, higher risks were observed in middle to high-income communities. Significant risks were also observed in Thailand, Australia, and Brazil for all-cause diabetes. In Thailand and Brazil for type 1 diabetes, in Thailand and Australia for type 2 diabetes, and in New Zealand for unspecified diabetes. This table shows what the proportion of diabetes hospitalizations can be attributable to exposure to white-fire PM2.5. Overall, an estimate of 0.67% of all-cause and 1.02% of type 2 diabetes hospitalizations can be attributed to white-fire PM2.5, corresponding to 23,544 and 15,215 attributable cases, respectively. We estimate a higher burden of white-fire PM2.5 attributable hospitalizations for all-cause type 1, type 2, and unspecified diabetes in high-income communities. Thailand and Brazil reported the highest number of diabetes hospitalizations attributable to white-fire PM2.5. Comparison between white-fire and non-white-fire PM2.5 is displayed in figure 5. Panel A is the average daily exposure concentrations. Panel B is the proportion of hospitalizations attributable to PM2.5 from wildfire and non-wildfire sources. And panel C is relative risks. Let's first look at panel C. The blue color is the wildfire PM2.5, and the yellow color is non-wildfire PM2.5. Compared with non-wildfire PM2.5, wildfire PM2.5 had a stronger association with hospitalizations for all-cause type 1 and type 2 diabetes. In panel A, the average daily exposure concentrations of wildfire and non-wildfire PM2.5 is 2.98 and 12.50 micrograms per cubic meter, respectively. So PM2.5 from wildfires only constitute a small proportion of the total PM2.5, which is around 90.3%. However, if we look at panel B, we could notice that wildfire PM2.5 surprisingly contributed to a non-negligible proportion of PM2.5 linked hospitalizations of diabetes, which is 38.7% for all-cause diabetes and 72.7% for type 2 diabetes. In conclusion, we found that shortened exposure to wildfire PM2.5 increased risks of diabetes hospitalization. Higher susceptibility was observed among individuals in advantaged communities and the residents of Thailand, Australia, and Brazil. Compared with PM2.5 from non-wildfire sources, PM2.5 sourced from wildfires posed a greater risk and burden of diabetes hospitalization. And finally, wildfires might be an emergent source contributing to the PM2.5 linked diabetes burdens. Here, I want to take this chance to thank my supervisors, Professor Shandy and Professor Jiang Ning, for their patient guidance and advice. Thanks to Professor Yu Ming and all the team members of our care unit and all of our collaborators. Thank you so much for your interest and attention. I would be happy to answer any questions you might have.
Thank you so much, Yiwen. That was for sharing that amazing work. So now we'll open the floor for any questions that the attendees may have. We had one question in the chat for Akim. I know, Akim, you answered that already in the Q&A section, but probably you can also answer it live. So the question was, while noting its small effect size, is the overall public health impact of air pollution and type 2 diabetes higher than the public health impact of obesity on type 2 diabetes? They were just wondering if the relative public health impacts of air pollution and obesity on type 2 diabetes had been quantified anywhere.
Yeah, thank you very much for this question. I'm sorry for being misunderstood and not clear enough. My point was to say that even a small relative risk might have an impact. I did not say that this public health impact of air pollution exposure is stronger than that for obesity, and I think this is not the case. And another participant from the webinar also asked the question whether I'm aware of the public health impact of obesity for diabetes. And I think the global burden of disease, one of the global burden of disease studies, which compared different environmental and lifestyle risk factors, nicely showed that that compared the two risks in relation to the onset of diabetes. But on top of my head, I cannot remember which effect was stronger. And my only gut feeling is that obesity is a very strong risk factor for the onset of diabetes, and which might be even stronger than ambient air pollution. And this is also likely because when you're looking at the entire story that ambient air pollution has an interrelationship with diabetes is rather it is recent. So this came up within the last 20 years, while it is very well known since many, many decades that obesity is not a healthy lifestyle factor for the onset of diabetes. Does this question, my answer respond to your questions? Are you fine?
Yeah, I think that was a great answer, and I think it does answer that question from the anonymous attendee. So Jeff Morgan had a question. Is there much variability in the effect sizes? I think that's what AF means. Or Jeff, please correct me if I'm wrong, for fire smoke and diabetes by location.
Okay, thanks for your question, Jeff. Yes, in our study, we did observe a significantly difference in the AF by countries and territories. While at the community level, we did not test the heterogeneity in the AF across communities, but we can do this in the future, and we can consider to test this in the future. But we did observe a significant difference in the AF across countries and territories.
Thanks, Yiwen. Just a follow-up for that question, because I'm quite curious. So why do you think that the vulnerable populations came from middle to high income countries? Is it because the wildfire is more prevalent in these countries?
I think this can be one aspect. On other aspect, I think maybe two factors may contributed to the vulnerability of the individuals in middle to high locations. Because in our common sense, we maybe would expect a higher vulnerability in low-income communities. So for the vulnerability in middle to high communities, first, the underestimation of diabetes prevalence can play a role because in many low-income communities, people there might tailor their behavior of seeking medical help and medical service constrained by their maybe disadvantaged financial conditions and a lack of knowledge. So this can result in an underestimation of the maybe hospitalization for diabetes. And the second factor could be the age structure of the high-income communities. Actually, to further explore this, we conducted further age-stratified analysis across high-income locations for type 2 diabetes, where we observed a significant high risk compared with their counterparts. And we found that the association between wildfire PM2.5 and type 2 diabetes was only observed among individuals aged over 60 years old. So, and this aligns with a prior South Korean study that the air pollution may exacerbate the existing diabetic conditions of this group of people due to their higher vulnerability to air pollution. And that may be exacerbated by the ongoing population aging in the middle to high income locations.
Thank you so much, Yiwen. For Akib, so for the short-term effects of air pollution and diabetes, did the studies observe similar like effects to what Yiwen found, which is like up to 4 days, or did they find different findings? Akib?
Yeah, I'm sorry. Could you repeat your question, please?
Yeah, sorry. So the narrative review of your systematic reviews, did the studies included in these reviews find a similar association to what Yiwen found, which is a lagged effect of up to 4 days on diabetes? Yeah, did they report the similar kind of findings or for the lagged effects?
You mean in relation to the short-term effects, right?
Yeah, correct.
Yeah, so what we did in our systematic review is we tried to come up with a synthesis of all the short-term effect studies in relation to prevalence and incidence of diabetes. We did the same for long-term effects, and in addition for predisposing factors like glucose intolerance. So that means our intention of this systematic review is to get a rather comprehensive overview on short-term effects in combination with the long-term effects and in combination with experimental studies, which gives you some insight on pathomechanisms, and to say, okay, this is what we what epidemiologists found is more than just an association, but to show that it is consistent across different study designs. It is consistent in relation to different regions. It is consistent also in relation to some predisposing factors. And this was the general idea, where we tried to make a very strong point on the overall association between ambient pollution and diabetes. And if you ask me whether how strong I'm convinced about, and I could very, very honestly say I am convinced. I'm less convinced in some other parts which are related to the role of NOx and the exposure to nitrogen dioxide. But for particles, I'm very strongly convinced that this reported association is real and is also causal. There is a lot of evidence for that. And this is the take-home message. And I try to cover the overall take-home message a little bit to some methodological issues, just as a learning experience for the students, because all the students, when you are starting to cover a specific research topic, all the students have to know what is the current what is the current knowledge about that, and what the smartest of the students are doing. Okay, they're trying to get a full picture when they are focusing on good systematic reviews. But what they should, my one message is, don't trust the systematic reviews without reading the original papers, to identify gaps in the knowledge, to identify also weaknesses in the association. And this was the intention of my talk.
Thanks, Joachim.
Sabrina.
Yeah, I think it's great that you outline those methodological limitations. So, you know, like the studies that you pointed out had wrong typos and scales. Like have they been corrected now, or they're still published in the literature and they're still wrong?
Yeah. So what I did, I sent an email to the corresponding author and asked whether I have misunderstood something.
Yeah.
No answer from the corresponding author. Then I sent an email to the editor of the journal where the paper was published, and the editor of the journal said, okay, I don't remember whether it was a she or he. He or she responded, okay, they will send a message to the corresponding author. And it takes a couple of months, and then the corresponding author came to me saying, oh, I'm very sorry for that. This was the fault of one of his students, and he blamed the doctoral students and said, okay, he have not double-checked the very last paper before submission, and so it is not his fault. At the end of the day, he did not correct or retract the paper, but I sent an a few lines to the editor, and these few lines were added to the paper. So that means you, as a student, you might look at the whole picture. If you found a paper, you also should look or double check whether there are commentaries on the paper. And so, and actually, this happened several times in different aspects. And actually, I would not do that again, because it is at the end you are distributing bad mood to the authors and also to the editors. And so it is the task of a cautious researcher to double check how to cite, which paper was cited, and whether the citation is justified. Thank you for this question.
Thank you so much, Akim. That was very interesting. Yeah, so we only have 3 minutes left, so I'll conclude today's webinar. Before I do that, I just want to extend my sincere appreciation to Yiwen and Akim for their excellent presentations on this topic. We hope the attendees have found the information valuable and insightful. And if you have any further questions or would like additional resources, please don't hesitate to reach out to the Center for Safe Air. We look forward to seeing you at our next webinar, which will likely be on fuel and transport, to be held in mid-September. We'll send out invites for this upcoming webinar soon after we have confirmed the speakers. Thank you and have a wonderful day, everyone. Bye-bye.
Bye-bye. Bye-bye.